In lecture number 14, we were dealing with NAND gate. So in this lecture, we will be dealing with the next universal gate, that is NOR gate. So the scope of this lecture is Introduction to NOR gate and an inverter realization using NOR gate. So coming into NOR gate. It is also known as NOT OR gate. NOT OR gate. Okay. So if you are having the representation of a NOR gate, you can represent it like this: A, B, this is the representation of a NOR gate. So what is X? What is OR? Is A or B? What is NOT OR? Is A or B, the whole complement. Now if you are writing the truth table of NOR gate, you can write like this: a two input NOR gate, I can represent like this. Inputs are A and B and output is X. Okay. So it is 0 0 0 1 1 0 1 1. What is 0 or 0? 0 is 0, its complement 1. 0 or 1 is 1, 0. 0. 1 or 1 is 1, it is 0. Now if you are writing the output of an OR gate, like output is equal to A or B, 0 or 0, it is 0. 0 or 1, it is 1. 1 or 0, it is 1. 1 or 1, it is 1. Therefore we can see that X is the exact complement of A or B. So you can write H is equal to A or B, the whole complement. Okay. So this is the basic truth table for two input NOR gate. Okay. This is also known as NOT OR gate. If you are going for more than one input, you can write like this: H is equal to A or B or C or D or etc. the whole bar. So here how will you define a NOR gate? Here the output is logic 1 if and only if all the inputs are logic 0. Okay. If all the inputs are logic 0, then you can say that the output of the NOR gate is logic 1. Okay. Now if I am giving an example of 3 input NOR gate, 3 input NOR gate, then I can draw the truth table like this: input is A, B and C is 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. Okay. So this is output is X. So how do you draw the truth table? If output is logic 1 if and only if all the inputs are logic 0. Okay. So it means for this one it is only logic 1. For all others it is logic 0. Okay. Now if you are writing the OR operation like A or B or C, how will you get? 0 0 0 0. This is 1 1 1 1 1 1 or 1 or 0, it is 1. 1 or 1 or 1, it is 1. So if you are comparing these columns, you can see that H is equal to A or B or C, the whole bar. So how will you draw the corresponding gate? You are having A, B and C and the gate is like this. Okay. So it is H is equal to A or B or C, the whole bar. Hope you have understood the concept of NOR gate. Next one, I am going to realization of NOR gate using resistor transistor logic. That is RTL. Using that is RTL logic. Okay. So first of all, let me draw the circuit. So here I am having two inputs, A and B. A is connected to a transistor T1. Okay. B is also connected to another transistor. That transistor is transistor that is T2. Here both of these the emitters are grounded. Okay. Now here what I am having is a plus 5 volt with a resistor R. Okay. Now I am taking the output across the collector of the two. So this is H, this is the output V naught. I am taking it across the ground. Now I have the following cases. So I will give the values of A and B. First, A is 0 volt, B is 0 volt. A is 5 volt, B is 5 volt. A is 0 volt, B is 5 volt. A is 5 volt and B is 0 volt. So in these cases, let us examine how this circuits work. So case 1. I am going with case 1. Case 1 is A is equal to 0 volt and B is equal to 0 volt. When A is equal to 0 volt and B is equal to 0 volt, okay, A is equal to 0 volt and B is equal to 0 volt. In this case, what happens? There is no base voltage for T1 and T2. Okay, so T1 and T2 is remaining off. If T1 and T2 is remaining off, then what happens? If T1 and T2 is remaining off, what you can get is the output voltage is directly the voltage across this resistance. That is, this V naught is approximately equal to 5 volt. Okay, equal to 5 volt. You can complete the circuit like this. Okay, that is when A is equal to 0 and B is equal to 0 volt. Next case. Next case is when second case, A is equal to 5 volt and B is equal to 5 volt. When A is equal to 5 volt and B is equal to 5 volt, here what happens is that base drive is therefore T1 and T2. Therefore T1 and T2 is on. Therefore the circuit can be completed like this as well as like this. Sorry. Right. Okay. That means here what happens is that the T1 and T2 here acts as short. Therefore what happens? The output voltage becomes 0. Output voltage becomes 0 volt. Okay. Now coming to the next case. Coming to the third case. Third case. That is when A is equal to 0 volt and B is equal to 5 volt. So A is equal to 0 volt and B is equal to 5 volt. When A is equal to 0 volt, what happens is that the transistor T1, that is A is equal to 0 volt and B is equal to 5 volt. In that case, what happens is that transistor T1 is not getting enough base drive, whereas transistor T2 gets enough base drive. So what happens is that the circuit will get completed by this. That means you will get a direct short between this 5 volt and ground. Therefore, you will get the output voltage V naught is equal to 0 volt. So here what we can see is that T1 is off and T2 is on. Okay, so that is regarding A is equal to 0 volt and B is equal to 5 volt. Now coming to the last one. Last one is so last one is coming to the last one, this fifth one. Sorry, fourth one. In fourth one, what we can see is that A is equal to 5 volt, A is equal to 5 volt and B is equal to 0 volt. In this case, we can see that when A is equal to 5 volt, A is equal to 5 volt and B is equal to 0 volt. In this case, we can see that the transistor T1 acts as a switch, whereas transistor T2 is will not get the base circuit. Therefore, we can get. Therefore, it is like T1 is on, but T2 is off. So what happens is that this the circuit will be completed via T1 to the ground. Therefore, in that case, what happens is that the output voltage becomes 0. Okay. So if you are writing X from here, you will get 0, 0. You will get the output as 5. For all other cases, you will get output as 0 volt. Okay. So that is the realization of NOR gate using resistor transistor logic. Okay. So coming to the next part of this lecture, the next part is realization of NOT gate using NOR gate. So NOR gate, it is basically an inverter. Okay. So what is basically NOT gate? Here we get A bar. So what is basically NOR gate? Okay. So we are having A, B. Here we get A or B bar. Now, if B is also equal to A, what happens to the output? If B is also equal to A, then what happens to the output? That is a question. If B is also equal to A, if B is also equal to A, then what happens to the output? In this case, the output becomes A or A the whole bar. What is A or A? What is A or A? If A is 0, 0, 0, that is 0. 1 or 1, that is 1. So here what we can say is that is basically A itself. A or A is basically A itself. This is A itself. Okay. So what we can say is that is A, that is A bar. Therefore, we can, how do you realize a inverter gate or NOT gate using NOR gate? So here what happens is that you are having two inputs. Here A and the first input is also A. So you can realize this A and short the two inputs, give the NOR. So you will get S is equal to A or A the whole bar, that is equal to A bar. That is how we are realizing an inverter gate or NOT gate using NOR gate. Okay, hope you have understood the concept of NOR gate. So in this lecture we have dealt with what is a NOR gate, a basic two input NOR gate, its symbol as well as truth table. Similarly, a three input NOR gate. Then we have here realized NOR gate using resistor transistor logic. Then after that we have dealt with realization of an inverter gate or NOT gate using NOR gate. So in the next lecture we will be dealing with exclusive OR gate, XOR gate and XNOR gate. That will deal with in the next lecture. After that we will study about some Boolean laws. After studying the Boolean laws, we will come back and how to realize all these gates using this universal gates. That will deal with.